what we're going to quickly look at today is we looked at expected value, which really is just the mean of a set of data. We're talking about discrete values. The mean sometimes seems like a bit of a strange thing to consider because the values that you get for the mean may not be the exact values that you can possibly get, but we're sort of used to that in sporting stuff. These stats are used lots for sporting greats and things like that, so it's a good example up on the board. If we work out the mean number of aces, we've got two tennis players and they serve a certain number of aces every set that they play, then we could work out a mean. Remember from yesterday's lesson, the expected value, say for Michelle, we would say, okay, we need to get the sum of each of the probabilities multiplied by their number of aces. So we would have 0 times by 0.1 plus 1 times by 0.15 plus 2 times by 0.45, etc., and get through there. And we would get a value. And the number of aces, looking at that, looks to me like it's going to be somewhere between 2 and 3 without doing the maths for it. So it's going to be probably 2 point something. But obviously that is an average. It's the expected number of aces they would get every set. It's not the exact because they can't get more than, they have to get either 2 or 3. They can't get a decimal value, but we're used to that. What we're going to do is do the second thing that you will learn in statistics already, and that is to say, okay, the mean or the middle of the data might tell you something, but how is the data spread out also matters. Okay, now it looks like actually, if I read further, I was wrong. It's not between 2 and 3. Perhaps if we actually work those out, I'm not going to do it, but you can work those out. It looks like they're telling us that the expected outcome is going to be 2 aces per set. So perhaps it does work out nicely to be 2 exactly. And it works out for 2 exactly for both those two players. So the statistic that says the expected value for Michelle and Amanda is that they serve 2 aces a set means that we can't do anything more to say anything about the 2 tennis players, whereas perhaps if we've got all the data, which we have here in front of us, we can see that perhaps Michelle is maybe a little bit more consistently serving 2, only very rarely doesn't get any, and certainly very, very rarely gets 4, so most of the time is 1, 2 or 3, whereas Amanda's data is spread out a little bit more, and 20% of the time is getting 0, but 15% of the time is getting 4. So the data is spread out differently. So the things that we measure spread with in the past was, you would do your box plots and that sort of thing. We're not doing those, but you could do box plots and look at quartiles and work out how much data fits in each spot. What we're going to look at is the standard deviation. Okay, now the standard deviation in a small data set sometimes doesn't mean a lot, but we can do it mathematically, and we're going to look at how mathematically we do it. You're not going to do much of it manually. You're either going to be given what the standard deviation is, or perhaps use a calculator, which we'll quickly go through how to do it. Okay, so you'll notice in the textbook it talks about the variance and the standard deviation. They are related directly. The standard deviation is really just the square root of the variance. Don't really get stressed about variance. We'll just worry about the standard deviation. Okay, so we'll just use that formula. So their mathematical notation for it. Okay, we've already seen the expected mean. All right, remembering that we do use this symbol regularly for mean now, mu. Okay, and it's just the sum of each value times by its probability. Okay, as you go through all the possible outcomes for it. We've done that already. You'll notice that it then tells us how to work out the variance. Don't worry about that. Let's just look at the standard deviation. It's the sum, okay, of the value. So each value, take away whatever the mean was. So effectively, if I was looking at, I'll just go back up to this data here for Amanda so we can see both bits. We're going to look at each of the possible outcomes. So we've got 0, 1, 2, 3, 4 aces. Okay, so they're going to be the values that are here. Okay, and for each of those values, we're going to take away whatever the expected value or the mean was. Now, if the mean is 2, which we assume it is, then our first one is going to be 0, take 2. Okay, but then we're going to square it. So that removes the fact that it's negative. It's really just working out how far away is each of the values from the mean, and then the square of that, how far they're away. Okay, and then adding them all up. Okay, so we'll look at the example they've got and show you, okay, you can do it manually, all right, and then we'll look at the calculator version of it, and really that's all we need for this part. So this example was from earlier up in the book about magazines. I think we might have gone through it at some point. But it talks about the customers buying a magazine in the shop. They either buy 1, 2, 3, 4, or 5 magazines. The probabilities are given. Okay, it tells us what the mean's going to be. We could work that out, but example 6 prior to that has already worked out the mean. Okay, so we know that the expected outcome is that each customer buys 2.39 magazines on average. Okay, to work out the standard deviation, then what we're saying is we take each of our values, so there's the 1 and there's the 1, take the 2.39, which is the mean, and square that whole thing. Okay, then, and that's what I forgot to say, in fact I forgot to say that last bit there is multiplying by the probability, then we multiply that by the probability of that event occurring, so the probability is 0.23. So this part here is like the first bit, okay? And we're just continually adding those up. That's what the sum notation is about, okay? So the next one is going to be 2, all right? So there's your 2 minus the 2.39 mean, all squared, and then multiplied by the probability of the 2 occurring. Okay, so you can see it's pretty straightforward, but it's going to be, as soon as you've got a few values, it's going to be a pain in the bum to do. Like, it's just, you know, you're not going to be asked to do something any more than that many, because it's just repeating the same thing over and over again. Okay, so what I want to look at is how to do this on the calculator. Hopefully I'll get it right, because this is the Texas one. But if you can see on the calculator, I'll leave all this as it is. To get into that list mode, it's go to the list. No, it's not. By myself, it's just hit the stat button. Oh God, no, it's not either. What am I? Yeah, so hit the stat button, and you want to edit your list. Okay, if you've got data in there, you'll need to take it out. All right. What we're going to do is we're going to put this list in. We're going to need both bits, because you know that you need to calculate not only the value that you get, so the 1, 2, 3, 4, 5, but also the probabilities of those things occurring. So down your list, you'll need to do 1, 2, 3, 4, 5, enter, and then next to it in list 2, put the corresponding probabilities of it occurring. 0.21, 0.13, 0.05. Okay, and once that's in there, you can then go back to your stat button and go across to calculate. And we're using one variable, so we're doing the one variant stats. So we're going to enter into that one. And it's going to ask you, what do you want to find out the stats about? Well, it's list 1 that I've got them in there. So that part's okay. So we can enter that line. But the frequency list is important. If you leave it blank, it just assumes that list 1, which is 1, 2, 3, 4, 5, they're the values you've got. You've got 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. What we're going to say is, no, we didn't get that. What we've got is 0.231s. Now, that's not, it's not saying that you got 0.23 of them. It works as though 0.23 of the time you got 1. Now, if you had a list that was just numbers, okay, I don't know, did you use this in stats before, where you might have had a list and just put the whole list of numbers in? You might have also put a frequency table in and said, okay, well, I had 3 1s and I had 5 2s or whatever, and you just put in this the frequency. Well, the probability can go in that same spot. So that one needs to be list 2, and someone's going to tell me how I get list 2 in there because it's different to this. How do I make that be list 2?
That's second stat.
That's second stat as well? Oh, yeah, right, and I can choose the list. Oh, just second as in, oh, yeah, L2? Oh, yeah, okay, so that's good, right, good. So anyway, that's important we got there, and then once we're down on calculate, it'll do the calculate, it'll bring up a screen that will give us the stats that are there for that data. Now, that screen, they use an X with a bar over the top for the expected value. That is okay. That's really about whether it's a sample of population. We're not going to worry about that for this point in time. But you can see you get 2.39. Okay, that's the mean. Okay, if we go down to this value that's down here, okay, which is the standard deviation, okay, we get 1.12. There's our 1.12. Okay, there are other values that are found in this list as well, which we don't necessarily need to worry too much about at this point. But you can go down and see that the minimum value is a 1 that could possibly happen. It does the box plot type stuff as well. It doesn't have a mode because this set of data doesn't work like that. I don't know. You got into that, Narav, on yours on the Casio? Do you know? I'll show you where to do it. Yeah, in there. It ends up looking like a similar screen like this when you get there, but that's important.
Yeah, I got there, but I think I've entered it wrong.
All right. Okay, so anyway, the values are there for you, so you can access it that way rather than having to do it by hand, because by doing it by hand is just an exercise in tedious, being careful with your calculations. You're not going to get something like that in a test that would be any longer than this many values to put in. In fact, you may not even get a question exactly like that in a test. What does that tell us, though? It tells us that the standard deviation from the mean is 1.12 ACEs. Okay, so what we're sort of suggesting is that, remember the old normal curve and the 68%? Remember those sort of values? We'll come back to that when we do the normal stuff and the continuous variables next. But it's saying pretty much 68% of the time, or 68 point, whatever it comes out to be, you're going to be within a, 2 point, sorry, this is not ACEs, this is about the magazines, isn't it? That the person's going to buy 2.39 magazines minus 1.12 and 2.39 magazines plus the 1.12. It's basically saying that about 68% of the time, the number of magazines is going to be bought is between those two values. Okay, that's what it's telling us. That's important because if there's a big spread, then we know that there's a lot of variance in the data. If it's a very small standard deviation, we know it's not spread out very much. It's all very much centered close to the mean. Okay, so that can give us some information about the spread of the data. So the questions from the actual textbook are using some of that and just working through that. Make sure that you can, one, use the calculator to get the value you need. Do understand that's the formula, okay? But you shouldn't spend too long on this because it's not something we're going to get tested heavily on. We're going to be looking at using it more. Okay.